As you probably already know, Sylvan and I share videos about our foraging lifestyle on social media. We never say that everybody should live like us or the way that we live is better than how other people live, but we very often get comments from people saying something to the effect of, if other people started living like you, then the ecosystem wouldn't be able to support and feed our society. People comment this like it's an obvious fact, but it actually couldn't be further from the truth. The thing people seem to forget when they're thinking about the impact of foraging on our ecosystems is that the alternative to foraging, which is commercial agriculture, requires clear-cutting forests and uprooting prairies. In my opinion, that's a lot more destructive to an ecosystem than foraging. For every one person that exits that global food production system, that's a little bit less space that's required for commercial agricultural purposes. Let's imagine for a second that everybody on Earth wanted to live like us, which they definitely don't. And all of that agricultural land could be converted back into forest and prairie. Would we actually be able to produce enough calories to feed the people in the same way that we are with commercial agriculture? Well, it turns out we would probably be able to produce more calories with less space and fewer inputs. The primary staple crops grown for calories in North America are corn, soybeans, and wheat. And these are used to produce the processed foods and meat that people eat every day. So I'll use these as the example for a typical agricultural yield in commercial agriculture. Grain corn is one of the most calorie-dense crops on Earth, and it can produce about 16 million calories per acre in a commercial setting. Soybeans produce about 6.2 million calories per acre, and wheat produces about 4.2 million calories per acre. Now let's see how the calories produced per acre for some of the wild foods in this course compare to their cultivated counterparts. According to the University of New Hampshire Extension Agency, oak trees can produce up to 250,000 acorns per acre in a good year. On average, there are about 60 acorns in a pound, so that would be over 4,100 pounds of acorns per acre. Processed acorns have about 1,700 calories per pound, so that would be about 7 million calories per acre from acorns. According to the Iowa State University Extension, black walnuts can produce up to 2,000 pounds of black walnuts per acre. At the high end, a black walnut is about 36% usable nut meat by weight, so that would be about 720 pounds per acre. Black walnuts have about 2,800 calories per pound, so black walnuts produce over 2 million calories per acre. According to Dr. Patrick O'Malley from the Iowa State University, pawpaws, which are an understory shrub, can produce 14,000 pounds of fruit per acre. Pawpaws have about 360 calories per pound, so that's over 5 million calories per acre from pawpaws. From these back of napkin numbers, we can see pretty clearly that any one of these wild foods is roughly on par with the calories per acre produced by commercial agriculture. But when you think about the fact that in a single acre of mature forest, all of those wild foods can grow together, it's pretty clear that wild foods in a forest blow commercial agriculture out of the water when it comes to calories and nutrients produced per acre. And that's not even to mention all of the mushrooms, small fruit and nuts, ecosystem services like wildlife habitat, carbon sequestration, water filtration, and oxygen production that a forest provides. Furthermore, wild food doesn't require all of the intensive inputs like fertilizer, pesticides, herbicides, and water that commercial agriculture requires. So that calories per acre number for commercial agriculture isn't entirely accurate because it doesn't factor in all of the space that's needed to produce those inputs to grow the crops on that acre. If you factored in all of the space that it takes to produce those inputs, the calories per acre for commercial agriculture would be even lower. The primary benefit of commercial agriculture, and the reason that it's the dominant way that our societies feed themselves, is that it's much less labor intensive. One person on a $500,000 tractor can harvest an entire acre of soybeans in less than an hour. On the other hand, a forager processing all of the black walnuts and acorns in an acre of land would take them weeks of completely dedicated work. This is obviously not something that everybody wants to do, and that's totally fine. But the idea that commercial agriculture uses less land or is less harmful on the ecosystem than foraging is just simply not true in most places. Sylvan and I do produce a lot of our calories through small-scale agriculture, where we grow flour corn, dry beans, pumpkins, squash, and potatoes in our gardens, and we think that sustainable agriculture has an important role to play in feeding our societies. We don't see foraging versus farming as an us versus them situation, but rather two complementary elements of building a sustainable food system that's also manageable from a human labor standpoint. And remember that all of the numbers in this section are just back of napkin estimates, so none of them should be taken as hard data, but rather just general ballpark estimates. And just as agricultural yields vary from year to year based on pest pressure and weather conditions, the same is true of wild food. Eventually, as homegrown hand-gathered continues to grow and evolve, Sylvan and I would love to start doing some research to generate hard data on the calories produced by wild ecosystems and how much can be sustainably extracted for human consumption at a large scale.